To Sri Krishna Educational Channel. In this video, I am going to explain about diazonium salts, nomenclature, preparation method, physical and chemical properties. This diazonium salts belongs to amines chapter of class 12th chemistry, chapter number 13. First, let me discuss the diazonium salts. The general molecular form of the diazonium salt is Rn2 plus X minus. That is the general molecular form of the diazonium salts, where the R, which is nothing but the aromatic group, X, it may be the Cl minus ion, Br minus ion, HS4 minus ion, Bf4 minus ion, or Cn minus ion. Okay, any of these ions which can be considered as X in the case of the diazonium salts. Next, the nomenclature of the diazonium salts. So the naming of the diazonium salts as first we can write the parent hydrocarbon name, okay, which consists the suffix name as diazonium. Okay, in addition to that, it also followed the anion name, okay, as chloride, hydrogen sulfide, bromide, cyano. Okay, this can be consist in the case of the anion name. Here the N2 plus group, okay, which is called as diazonium group. N2 plus group is known as the diazonium group. Okay, for example, if we consider C6H5N2 plus Cl minus, okay, which is named as the benzene diazonium chloride. First we can write the hydrocarbon, that is the benzene. Okay, next one is diazonium. Next followed by the anion name is chloride. Okay, another example C6H5N2 HSO4 minus, which is the benzene diazonium hydrogen sulfate. So this is the name of this compound. So this way we can write the name of the diazonium salt. Here the primary aliphatic amines, so those form highly unstable alkyl diazonium salts, and the aromatic primary amines, okay, that can be forms arene diazonium salts, okay, which are stable for short time, and in the case of the solution at a low temperature, that is 273 to 278 Kelvin, that is 0 to 5 degree Celsius. So at that temperature which is stable, okay, that is for short time in the case of the arene diazonium salts. But the alkyl diazonium salts which are unstable, here the arene diazonium salts which are stable, that is due to it can be undergoes the resonance. The arene diazonium ion which can undergoes the resonance. So you can notice here the arene diazonium ion undergoing the resonance. Here the double bond present between the first carbon and second carbon, which is delocalizes towards nitrogen and the first carbon. So as a result it can get the double bond, and that among the triple bond, so one of the bond which can be moved toward the nitrogen, so nitrogen gets the negative charge. Okay, now the first carbon gets the positive charge to satisfy that the double bond present between the third and fourth carbon, okay, which can be moved towards the second and third carbon. So that case it will be again the positive charge which can be observed at the fourth carbon. So one more resonant structure we can obtain. So that case we can get the positive charge at the sixth carbon. So this way the arene diazonium ion which is stable due to resonance, but the alkyl diazonium ion which is unstable because it doesn't undergoes resonance. Next, the preparation methods of diazonium salts. Okay, diazonium salt which is simply nothing but what, C6H5N2 plus Cl minus. Okay, it can be prepared by the reaction of aniline, okay, with nitrous acid at the temperature 273 to 278 Kelvin. The nitrous acid simply obtained by the reaction of the sodium nitrite with hydrochloric acid. That case we can get the nitrous acid. The process of conversion of the aniline into diazonium salt, this process is known as diazotization. This process is known as the diazotization. Here this diazonium salt which is highly unstable, it is instability it is having, so it is unstable, it is not generally stored, okay, it is used immediately after the preparation. This diazonium salt which is okay, it is not much stable, so because of this reason, okay, which is not stored, okay, which can be used immediately after its preparation. Okay, for example, here you can notice C6H5NH2, which is treating with NaNO2 in presence of hydrochloric acid at the temperature range 273 to 278 Kelvin. So that case we can get C6H5N2Cl plus NaCl plus H2O. So this is the diazonium salt where N2, okay, which is having the positive and Cl has the negative charge on this. It is a diazonium salt C6H5N2Cl. So here the N has the positive and Cl has the negative. So it is known as benzene diazonium chloride. Next, the physical properties. Here the benzene diazonium chloride, which is a colorless a crystalline solid. It is readily soluble in the case of water and is stable in cold but react with the water when it is warm. Okay, when we are heating, so that case the benzene diazonium chloride, which can be react with the water and forms the compound of the water, but it is stable in the case of the less temperature, that is cold conditions, which is stable. It decomposes in dry state. Okay, in the case of dry state it will become decomposes. Okay, next benzene diazonium hydrofluoroborate, okay, which is water insoluble but stable at room temperature, which is water insoluble but stable at the room temperature. Okay, these are the physical properties of diazonium salt. Next one is the chemical properties. So in the case of the chemical properties, there is mainly two kind of chemical properties which can be involved by the diazonium salts. One is the reactions which are involving by the displacement of nitrogen from the diazonium salt. Okay, second one is the second type of the chemical reactions, which is the reactions which involving the retention of the diazonium group. So now first we can discuss the reactions which are involving the displacement of nitrogen. So here the diazonium group being a very good leaving group, it is a very good leaving group, is substituted by the other groups like Cl minus, Br minus, I minus, Cn minus, OH minus. So these groups can be easily substituted in the case of the diazonium group. So because it is a very good leaving group. So which displaces the nitrogen, okay, from the aromatic ring. The nitrogen formed, okay, escapes from the reaction mixture and it can be formed as a gas. First the replacement of halide ion or cyanide ion. So this is also known as the Sandmeyer reaction, which already discussed in the case of the previously. This in this case when the aryl diazonium halide, aryl diazonium salt, which is treating with CuCl in presence of hydrochloric acid. So that case we can get the aryl chloride. That is, if it is we are taking its benzene, so benzene and diazonium halide. That case we can get benzene, chlorobenzene. So if you are taking when the diazonium salt is treating with CuBr in presence of HBr, so that case we can get ArBr, that is aryl bromide can be obtained. Okay, whereas when the aryl diazonium salt which is treating with the CuCN, so in presence of potassium cyanide, that case we can get ArCN, okay, can be obtained. So all these cases, okay, this N2 gas which can be released out. Here N2 gas can be removed from the diazonium salt, and in presence of the N2 group, the halogen or cyanide group which can be take part. So here the Gutterman reaction, in the case of this the chlorine or bromine which can be also introduced in the C6H5 ring by the treatment of the diazonium salt solution with the corresponding hydrochloric acid in presence of the copper powder. So here the Gutterman reaction, in this case the chlorine as well as the bromine can be easily introduced on the benzene ring, okay, to the diazonium salt by the treating with the corresponding hydrogen halide in presence of the copper powder. So here the diazonium salt which is treating with copper powder in presence of the hydrochloric acid, then we can get ArCl plus N2 plus Cux. Whereas aryl diazonium salt which is treating with the copper powder at in the presence of hydrobromic acid, so that case we can get Ar aryl bromide plus N2 plus Cux can be obtained. So now this is known as the Gutterman reaction, when the reaction which is carried out in presence of the copper powder, whereas if it is treating with the copper halide or copper cyanide, so that case that reaction which is comes under the Sandmeyer reaction. Now among the yield of the Sandmeyer reaction and Gattermann reaction, the Sandmeyer reaction, okay, which is found to be better yield than that of the Gattermann reaction. When comparing with the Gattermann reaction, the yield which can be obtained in the case of the Sandmeyer reaction, which is, okay, good yield can be obtained. Next, the replacement by iodide ion. So in case of the replacement by iodide ion, and the aryl diazonium salt which is treating with the potassium iodide, so that case we can get aryl iodide plus potassium chloride plus N2. Okay, this way we can get the aryl iodide. The simple way we cannot get the iodide which can be present on the case of the aromatic ring, but by the diazonium salts we can easily obtain the iodide on the aromatic ring. Next, the replacement by the fluoride ion. So when the aryl diazonium salt, okay, which is treating with HbF4, okay, that is known as a fluoroboric acid. So that case it can be forms ArN2BF4 minus. Okay, when we are heating this, that case we can get okay, aryl fluoride plus boron trifluoride plus N2 gas can be obtained. So this is the replacement of fluoride ion. Next, the replacement by hydrogen. So in this case, when the aryl diazonium chloride which is treating with H3PO2, that is known as phosphinic acid. So in the presence of the water, in case it form, the corresponding arene can be obtained. Okay, if we are taking benzene diazonium chloride, then we can get the benzene. Okay, plus N2 plus H3PO3, that is phosphorus acid can be obtained plus hydrochloric acid. So if you consider this H3PO2 to H3PO3, it can be converted. So this is phosphinic acid to phosphorus acid, it can be converts. So it can undergo the oxidation itself. Similarly, when the aryl diazonium chloride which is treating with the ethanol, so that case we can get the arene. If we are taking the benzene diazonium chloride, that case we can get the benzene. So plus N2 group plus here this ethanol can be converted into ethanol, it is aldehyde can be obtained plus hydrochloric acid. Here the phosphinic acid and ethanol which can undergo the oxidation to obtain the corresponding phosphorus acid and ethanol can be obtained. Next, the replacement by the hydroxy group. When the aryl diazonium chloride which is undergoes the hydrolysis, that case we can get the corresponding alcohols, aromatic alcohols can be obtained. If we are taking the benzene diazonium chloride, then we can get the phenol. On the benzene ring we can get the OH group, that is phenol. Next, the replacement by NO2 group. Here for the replacement by the NO2 group, so in this case the benzene diazonium chloride, when it is treating with the fluoroboric acid, that case which can be initially formed the salt of the fluoroboric acid, which is further treating with the sodium nitrite in place of the copper metal followed by the heating. That case the nitro group which can be take part on the benzene ring. In addition to that, it gives N2 plus NaBF4 can be obtained. So this way the nitro group which can be take part on the benzene ring. These are the reactions which are involving the displacement of N2. Now the next one is the reactions which are involving the retention of diazo group. Okay, this is these are the comes under the coupling reactions. So for this case, when the azo products, okay, which are obtained and have an extended conjugated system having both aromatic rings, okay, joined through the N double bond N bond. Okay, these compounds which are often consisting the colors and which are also used as the dyes. Okay, for example, the benzene diazonium chloride which is treating with the phenol. Okay, phenol. So that case the phenol, the para portion which is having the hydrogen, so that and the chlorine of this benzene diazonium chloride which can be leaved as hydrogen chloride, and the bond which can be take part between the nitrogen and the fourth carbon of the phenol. So in the this reaction which is carried out at a strong base, in the presence of strong base, so we can obtain the para hydroxy benzene can be obtained. Okay, para hydroxy azobenzene can be obtained, para hydroxy azobenzene. So it is also consisting the orange dye. Okay, plus hydrochloric acid and water can be obtained. Next, the benzene diazonium chloride, when it is treating with the aniline, so that case the aniline which is consisting the fourth position contain the hydrogen, okay, in the presence of strong base, so it can be again gives the chloride ion plus water plus the between the nitrogen and this aniline fourth carbon, between that the bond can be takes place, so that case we can get the para amino azobenzene can be obtained, para amino azobenzene can be obtained. So this is considered which is consisting the yellow color, so yellow ppt can be obtained. So these reactions also known as the coupling reactions, because okay, the diazo group is retaining, and in addition to that one more aromatic group which is attaching to this diazo group. So these are also having the different kind of colors which is providing, and those are also used as a dyes. Okay, this is the coupling reactions. Next, the importance of diazonium salts. Okay, diazonium salts, okay, which are good intermediates to introduce the fluoride ion, chloride ion, bromide ion, iodide ion, CN ion, OH minus ion, NO2 ion in the case of the aromatic ring. So that is, these are good okay, intermediates. Okay, in addition to this, hydrogen also we can introduce in the case of the aromatic ring, so that case we can get simple arenes. Okay, next okay, aromatic fluorides as well as the aromatic chlorides, okay, which cannot be prepared by the direct halogenation. By the direct halogenation we cannot prepare the okay, aromatic fluoride as well as the aromatic iodide, but by these diazonium salts we can easily prepare okay, the aromatic fluoride as well as the aromatic iodide. The cyanide group, okay, which cannot be introduced by the nucleophilic substitution reaction of chlorine in the case of the C6H5Cl, but C6H5Cn can be easily obtained from the diazonium salt. Okay, when the C6H5Cl which is treating with the KCN or HCN, that case we cannot obtain C6H5Cn, but from this diazonium salt can easily obtain the cyanobenzene. Okay, this is about the uses of diazonium salt. These are mainly used as the good intermediate to obtain the different kind of aromatic compounds. Okay, this is about the diazonium salts. Okay, thank you.